Hello, my name is Scott Clark, co-founder and CEO of SigOpt. In this video, I'm going to show you how SigOpt can help you amplify your trading models by optimally tuning them using our black box optimization platform. The SigOpt platform provides an ensemble of state-of-the-art Bayesian and global optimization algorithms via a simple software-as-a-service API. SigOpt optimizes trading and machine learning models with less trial and error by efficiently configuring the tunable parameters of these models. This results in captured performance that may otherwise be left on the table by conventional techniques, while also reducing the time and cost for developing and optimizing new models. Every complex system has tunable parameters. A car has parameters like the gear ratio or fuel injection ratio that affect output like top speed. Machine learning models have tunable hyperparameters that affect output like accuracy or error metrics. Algorithmic trading models have parameters like thresholds, weights, and data transformations that affect output like a back-tested performance metric. Domain expertise is incredibly important when developing algorithmic trading models, which often undergo rigorous backtesting before being deployed into production. Often, the expert needs to tune the model they developed to optimize a performance metric and maximize returns. This involves finding the best parameter configurations for all the various knobs and levers within the model, and can have a significant impact on end results. Traditionally, this is a very expensive trial and error based process that relies on methods like grid, random, local, or an expert-intensive manual search. SigOpt uses a proven, peer-reviewed ensemble of Bayesian and global optimization algorithms to efficiently tune these models. First, SigOpt suggests parameter configurations to evaluate, which are then evaluated on some backtest or simulation where an objective metric like a Sharpe ratio is calculated. This process is repeated, either in parallel or serially. SigOpt's ensemble of optimization methods leverages the historical performance of previous configurations to optimally suggest new parameter configurations to evaluate. By efficiently trading off exploration, learning more about the underlying parameters and response surface, and exploitation, leveraging that information to optimize the output metric, SigOpt is able to find better configurations exponentially faster than standard methods like an exhaustive grid search. All of this is accomplished by bolting our easy-to-integrate REST API onto your existing models. SigOpt's black box optimization algorithms require only high-level information about the parameters being tuned and how they performed, meaning sensitive information about your data and model stays private and secure. This results in dramatically improved performance over standard methods, as seen in this joint work with Quantopian. In this case, SigOpt was able to tune a trading strategy and beat both the standard method of exhaustive grid search and an expert performing a time-consuming and expensive manual search for a local optima. SigOpt found a model that produced 200% higher backtested returns than the expertly tuned configuration, while also requiring 10 times fewer evaluations than the standard grid search approach. Because SigOpt is a black box optimization platform, it is agnostic to the underlying model being tuned and can be readily used to tune any machine learning or AI pipeline as well. All SigOpt requires is continuous, integer, or categorical parameters to tune, like the hyperparameters of a machine learning pipeline, as well as a performance metric to optimize, like cross-validated accuracy. SigOpt makes no assumption about the underlying parameters or metric being optimized. It can even be a composite of many underlying metrics and does not need to be convex, continuous, differentiable, or even defined for all configurations. Every machine learning or AI model has tunable hyperparameters that affect performance. This can be as simple as the number of trees in a random forest and the kernel of a support vector machine, or as complex as the learning rate in a gradient-boosted or deep learning method. In this simple TensorFlow example, we have constructed a 4-layer network to perform 2D binary classification. We are attempting to learn a surface that can differentiate blue and orange dots, as seen in the figure to the right. Even this simple task and small network has 22 tunable hyperparameters, including traditional hyperparameters like learning rate and activation function, as well as regularization and architecture parameters, and feature transformation parameters. By tuning the parameters of this pipeline in unison, we can achieve much better results than tuning them independently. This extends to complex trading pipelines as well, which may incorporate many unsupervised and supervised learning techniques with tunable parameters in addition to the actual trading strategy itself. SigOpt provides best-in-class performance. We've successfully deployed our solution at firms worldwide and rigorously compare our methods to standard and open source alternatives at the top machine learning conferences. Our platform scales to any problem and provides features like native parallelism, multi-objective optimization, and more. Additionally, our black box optimization approach means that your proprietary data and models never leave your system, allowing you to leverage these powerful techniques on top of the infrastructure and tools you've already built. The SigOpt optimization platform integrates with any technology stack, and the intuitive dashboards shine a light on the otherwise opaque world of parameter tuning. Just plug our API in, tune your models, and your whole team benefits from the history, transparency, and analysis in the platform. SigOpt also allows you to tune any algorithm in parallel by acting as a distributed scheduler for parameter tuning. This allows you to tune traditionally serial models in parallel and achieve better results faster than otherwise possible, while also scaling across any number of independent models. SigOpt has been deployed successfully at some of the largest and most sophisticated firms and universities in the world. We've helped tune everything from algorithmic trading strategies to machine learning and AI pipelines and beyond. Contact us to set up an evaluation and unleash the power of Bayesian and global optimization on your models today.